Good morning, all. I, Nilima Warade, working as an assistant professor in the Department of Electronics and Telecommunication Engineering from All India Shri Shivaji Memorial Society's Institute of Information Technology, Pune. Today, I will be discussing on Tri-State TTL logic. Tri-state or three states logic means the logic allows an output port to assume a high impedance state, effectively removing the output from the circuit, in addition to the logic 0 and logic 1 levels. That is, it utilizes the advantages of high speed of operation of the totem pole configuration and wire ending of the open collector configuration. It is called the Tri-State TTL because it allows three possible output states as high, low, and high impedance Z. In high impedance Z state, both the transistors in the totem pole arrangement are turned off so that the output terminal is a high impedance to ground or VCC, or the output is an open or floating terminal, that is neither low nor high. The tri-states gates have additional circuitry via which the gate outputs can be enabled or disabled. This is very useful in digital systems where devices communicate via common wires called buses. Only one device can talk at a time. The others are disabled. The circuit has two input states as A, which is the normal logic input, and E as the enable input, which produces the high impedance Z. Now, I will explain you the operation of the tri-state TTL. As I said, the circuit has two inputs A and E, that is the enable. So we can say the enable state, that is E, can produce the high impedance Z. Therefore, when E is or the enable pin is at high, that is at logic 1, the gate is enabled and behaves like a normal inverter because high voltage at E has no effect on T1 or transistor T2. So in this enabled condition, the output is simply the inversion of logic input A. Secondly, when it is a disabled state, that is when E is 0 or low as shown in this figure, the output, or we can say the circuit, goes into its high impedance state regardless of the state of logic input A. The low at E forward bias the emitter base junction of the transistor T1 and shunts the current in R away from transistor T2 so that T2 turns off, which in turns makes T4 transistor off. The low at E also forward bias the diode D1 to shunt the current away from the base of the transistor T3, and therefore the transistor T4 also turns off. With both totem pole transistors in the non-conducting state, the output terminal is essentially an open circuit. This way, I can say, this way the tri-state transistor logic can operate. This is the symbol of the Tri-State TTL logic, where we have a simple inverter having an inputs A and E, which will generate the output Y. This is all for today's video. Thank you everyone.